Hello everybody, in this video we're going to learn what a polynomial is and how we can classify and write them. So before we can do that, we need to know what a monomial is, and that's just a mathematical expression that only contains one term. So a monomial could be one of a few things. It could be a variable, like x, it could be a number, like 3, or it could be a combination of the two being multiplied by each other, so 3x. And that's really just 3 times x, but we normally just say 3x. We can also have exponents in with our variables, so something like 3x to the second power, and x to the second power just means x times x being multiplied by itself. So that's what a monomial is. It could be a variable, a number, or a variable multiplied by a number. A polynomial is a mathematical expression that contains two or more algebraic terms that are added or subtracted. So it's basically a group of monomials that are being added or subtracted. So one example could be 3x plus 2. We have two terms, one being 3x, the other one being 2, and they're being added to each other. Another example, if we add some exponents with our variables, we can have 4x squared minus 2x plus 8. In this one, we have three terms that are either being added or subtracted. And let me just give you one more so we get a good understanding. So we have 5x to the third minus 8x squared minus 9x plus 2. And this one has four terms that are being added or subtracted. So the main idea is a monomial only has one term. A polynomial has two or more terms that are being added or subtracted. So when we classify polynomials, we like to classify them based on the degree of the polynomial and the number of terms a polynomial has. So the degree of a polynomial is basically the highest exponent that a variable is being raised to in a polynomial expression. So if I had the expression 4x to the third plus 3x to the second minus 8x plus 9, I could see that my highest exponent is 3, and thus we would call this a third degree polynomial. Now, certain number degrees are going to have special names to them. So we're going to start with 0, and a 0 degree polynomial basically means there's no variable there. And we're going to call this a constant. It's just a number. All right, and I'm going to write off to the side, there's no variable here. So it's like 3, it's 72, it's just a number. Now, a first degree polynomial we're going to call linear. Now, we can say that this does have a variable, but the exponent's not going to be shown. So no shown exponent. And the reasons why it's not shown is you're going to have something like 3x, right? And that x, it doesn't look like it has an exponent with it. But in reality, there's actually an imaginary 1 with that exponent. So if there's no exponent being shown, we can always put a 1 as our exponent. All right? For a second degree polynomial, we are going to call that quadratic. Third degree polynomials, we're going to call cubic. Fourth degree, we're going to call quartic. And then fifth degree, we're going to call quintic. And then beyond 5, we don't really have names, special names. So if we have a 6th degree polynomial, we'll just say it's a 6th degree polynomial. Now, for the number of terms, we've seen some of this before, especially with the one term, and we call this a monomial, where we have just one term, nothing's being added or subtracted to it. Now what's nice is our prefix mono, and that helps us see that it's one term. Mono means one. Now for two terms, we're going to call this a binomial, where bi means 2. 3 terms, trinomial, where tri means 3. And then after that, for 4 or more, we're just going to call that a polynomial. Now, one thing also to note with binomials and trinomials, since they are 2 or more terms, we are also going to call these polynomials. So, to classify each of these polynomials, we like to state what the degree is and how many terms each of our polynomials has. So we have 5 examples here where we want to do that. So our first example, we have x to the second plus 4. And we can see our biggest exponent is a 2. So we're going to call that quadratic. And we can see we have two terms, x to the second and then plus 4. So we're going to call that a binomial. polynomial. So altogether, this expression, x to the second plus 4, is a quadratic binomial. For our second example, we have 3x. And we notice that the exponent is not being shown with our variable. So we can put a 1 there. And we can call that then linear. Since we only have one term, we know this is a monomial. So altogether, linear monomial. Third example, highest exponent. We have a 3, we have a 2, and we have something, a 3 with no variable. So our highest exponent is a 3. And we know that's called a cubic. And we know we have 1, 2, 3 terms. We call that a trinomial. For our next example, it's just the number 5. There's no variable with this, so we call that a constant. And since we only have one term, just like with 3x, we call this a monomial. So a constant monomial. With our last expression, we have exponents of 4, 3, 2. We have x to the first, and then we have a minus 6. So again, looking for the biggest is 4. We call that a quartic. And since we have 1, 2, 3, 4, 5 terms, we're just going to call that a polynomial. Now, if you notice with the last slide, the exponents with our variables in each expression were written in descending order. So we always started with the biggest exponent, and we worked our way down to the smallest exponents to the terms that had no variables at all. And we call these standard form polynomials, where the exponents are written in descending order. And we like polynomials written this way, so they're easier to solve, they're nicer to graph, and just really easier to work with. So we have 3 examples here that we want to rearrange the terms to put them into standard form. So for our first expression, we have 5x minus 3 minus x to the second. And we want to rearrange these so the biggest exponent variable goes first, and then we work our way down. So I see that my biggest exponent here, well, the 5x has an exponent of 1, really. 3 has no variable, so there's no exponent there. But we see this negative x to the second. So that's the one I'm going to start with. So negative x to the second. And then 5x to the first is going to come after that. And I'll just write 5x. We don't really need that 1 there, but it's good to see that that exponent would be a 1 when we're ordering it. And then we have this minus 3 without the variable. And that would be that polynomial written in standard form. For our next example, 4x minus 7x to the fourth plus 38 plus 3x to the second. So I see x to the first, I see x to the fourth, x to the second. Biggest one is the 4. And I'm just going to write that expression with the negative 7, x to the fourth. Next expression, next exponent we're looking for is the 2. So that's 3x to the second. That's going to come next. Then I have 4x to the first that I'm going to add. And then I have the plus 38 at the end. For our last example, you notice we have more than one variable happening. And in examples like this, what we want to do for standard form is have the term with the biggest sum of exponents come first and work our way down. So sum meaning the addition of the exponents in each term. So for our first term, we have 3x to the fifth, so that's 5. For our second one, we have plus 5x to the third y. Again, that y has an exponent of 1 with it. And that's 4. And then our last expression has 4, 5, and 2 as our exponents. So that's 4 plus 5, 9, plus 2, 11. So 11 is our sum of the exponents. That term is going to come first. So we're going to write x to the fourth, y to the fifth, z to the second, because it has the biggest sum of exponents. Our next one is going to be 3x to the fifth that we're going to add next. And then lastly, we have 5x to the third, y. All right, and those would be those polynomials in standard form. I do hope you enjoyed this video, and I hope that you tune into some more in the future.